Welcome, everyone. My name is Nessa Posson. I'm a contributor experience lead for NumPy. If you're joining us now, please introduce yourself in the chat. I'd like to remind you that all attendees of NumPy community events must adhere to the NumPy Code of Conduct. The NumPy Steering Council has made a strong commitment to creating an open, inclusive, and positive community. If you haven't done it already, please read the NumPy Code of Conduct for guidance on how to interact with others in a way that make the community thrive. All attendees of our events must adhere to it. I wish for you all to have a positive experience at our events. And if you see violations, take a screenshot, intervene in a respectful manner, and report it to the COC committee via email. And I will post all the related links in the chat. And now I'd like to introduce our today's speaker. Ryan C. Cooper is an assistant professor in residence at the University of Connecticut, teaching computational mechanics, dynamics, amongst many other courses. He completed his PhD at Columbia University and also spent some time working as a postdoctoral research assistant at Oak Ridge National Laboratory. He has been using Python, Jupyter, and GitHub to enhance the classroom experience of his students for over 6 years. Professor Cooper has developed the open source materials, which are free for computational work in engineering, and a contributor to the NumPy documentation. Ryan, please take it away.
Thanks so much, Inessa. Thanks for having me, and I'm excited to share some of the work that I've been doing with NumPy and also Jupyter, but it's all big, happy, friendly ecosystem. But I did want to ask, so that's a little bit about me. Inessa did a great job introducing myself. I wanted to ask who else is on the call, if you're comfortable saying like what you're currently doing or maybe your background and what brought you here. I like to identify like who's in the learning community as we get started. So I know Inessa and Mars. Is that Sanya?
Hi, everyone. So I'm Sanya. I hope I'm audible to all of you.
Perfect.
So I'm from India and I'm currently studying electronics and communications engineering. I'm working at the University of Texas at Austin as an undergraduate research intern, and my field of research primarily encapsulates machine learning and deep learning around transportation planning. And I'm also very interested in computer vision, and I have 2 papers in IEEE transactions under review, which mostly encapsulate computer vision. So I have been using NumPy for quite some while as of now, but I never really had any formal training when it came to NumPy. So when I was actually subjected to this platform, in fact, Ricardo introduced me to this platform. So it was like super cool for me. It was an amazing experience for me, and I'm just here to learn. So looking forward to all of it.
Awesome. Thanks for sharing, Sanya. It sounds like you're off and running with NumPy, already using computer vision and all of that.
Yeah. So it's really cool.
Awesome.
And I would love to contribute to the code base or to the documentation in any way possible.
Yeah.
I'm Cody Rogers, and I've used NumPy for a few years off and on, mostly when I was studying at the University of Regina for like just working with some data. And I do sometimes at work, but I'd like to use Python more at work than I do now, but it's just that the stuff that was done before when I wasn't there, a lot of it was done in MS Access. So
yeah, it's a big transition. Yeah.
Yeah. So I get to use VBA, which I don't like. And yeah, I'd like to contribute to the to NumPy some way. I just haven't. I've been trying to for a while, but I haven't sort of made the time yet, I guess.
Yeah. Awesome. Thanks for joining. Good luck with your Visual Basic struggles.
It's a completely wackadoodle language.
Oh man, yeah. So I won't put anyone on the spot, but does anyone else want to jump in?
I will hold the fact that I programmed with Visual Basic in the past. So yeah, I'm Ricardo. Came from a background in mathematics, got into computer science, do some research in compiler optimization now. Have used NumPy for a while. I like to play with machine learning and artificial intelligence too. Yeah, I'm from Brazil, living in the US for quite a while, and happy to be here.
Welcome. I'll give a moment of awkward silence.
I think people don't want to confess that they all
That's
use
okay.
Microsoft
Yeah.
Office.
And I use the awkward silence to like let the courage build up, or someone just be so awkward that they have to jump in, but that's okay. Okay, so a little bit more about me. Let me share my screen and we'll jump, or actually before I do that, let me grab this one should be, so this HackMD has like links to the slides that I'm going to show, and then some exercises that I wanted to kind of ask you about, like in the classroom, like your last class, whether it's been a long time or you're still in the classroom, some questions about that. So, all right, let's share the screen now. Share here. Okay, it says participants can see my screen. So I've been using NumPy in the classroom, and like I said, I use kind of NumPy, SciPy, Jupyter, and it's all a big kind of happy ecosystem. But NumPy in particular is it's such a huge game changer for mechanical engineers. So I'm a mechanical engineering professor. There's still, I would guess, 3 out of 4 engineering firms are still using Excel for all of their like kind of computational work. So introducing new mechanical engineers to NumPy, this is a logical choice for getting them to speed up their computations and helping them think about problems in a new way. And then there's some added benefits that I want to talk about today, about the fact that NumPy is free and open source. Free is kind of the minimum benefit. Like even if I had to pay for NumPy, I would be happy to, because it's such a great community and there's so many great tools and it's open, but the openness is really the key. And we'll talk about that a little bit more. So I'm Ryan Cooper. This is my GitHub profile at Cooper RC. So if you see me jumping around, welcome to say hi or jump in. LinkedIn, feel free to connect with me on LinkedIn. I would love to branch out and learn more about you. As Inessa introduced, I'm a professor in residence, which means I teach 3 classes twice in every semester. So I teach about 6 or 8 classes a year here at UConn in mechanical engineering. I have 2 boys. One is 4, the other one's turning 7. I love running, biking, skateboarding. I like to road bike and mountain bike, and then trail running and road running, but anything outdoors. And there's a video. I won't show you the video since I'm like actually talking and we're making a video, a little too meta. If you want to access this presentation or even more resources, my GitHub personal page, so I'll open this link up. This has, again, it has my video, some contact information, but then also all of these open educational resources that I create. So there's one for applied dynamics, computational mechanics, and I'll come back and show these later. But these are all licensed under open source licenses, so you can take them, reuse them, kind of repackage them for anything, as long as you're not like I don't think you can profit off of them. I forget what the Creative Commons license restricts, but I think you just can't sell them as their, you can't repackage it and sell it somehow. And then this slideshow is here in this Cooper Newcomer 2022-06. Okay, So again, why do I use NumPy in mechanical engineering courses? Like I was saying, a lot of engineers use like Excel for a lot of their work. So using NumPy is a much better tool. But then under the core of that, as far as like an educational resource, where I want students to learn something, like come away from the class and have some kind of new knowledge. NumPy is open source, and the big thing here is that the code and the documentation are completely open. They're reusable and redistributable. So I could take huge chunks of documentation, put it into an open educational resource, and then give that to the students, like actually give it to them so they can reuse it and have either a portfolio or like they can build their own website. But the students, because all of my work is open, all of their work is inheriting that openness. So they can reuse that work, they can share it with other people. I can show, like, people can show me their websites, I can show other people websites. That's things that I get excited about. I like to show my family, like, hey, look at this cool thing that I was working on. But I think it extends even more than that to like job interviews and these kind of things. And then also it's an amazing tool set. It's really, I've been at NumPy, I've been part of the documentation team since about 2019, end of 2019. Then I was a season of docs writer in 2020. So I really love volunteering because the people are amazing, the community is supportive, it's inclusive. There's a lot of work put into like making sure that documentation and the tools are that everyone's able to use them. And applications for NumPy, I mean, it ranges everywhere from you could use it to balance your budget, or it was used for programming the Mars helicopter, now I can't remember the name of it, but the helicopter that's on Mars now, NumPy was used for that. Or even imaging those black holes, also NumPy was a big part of that, getting that information and processing there. So these are all really amazing tools and really amazing reasons to use NumPy in the classroom, and especially for, in my case, mechanical engineering. I think it would be great to see it in every class. So I have some questions for you now. So stopping for a second, you can either scan the QR code or head over to that link, that HackMD document that we had. I wanted to ask, like, the first question that I have is like, what's something that let me do this. What's something from a course that you took that you never shared? There's probably most examples from courses are things that you just never shared with people, but this could be like a paper that you wrote, an exam, a homework assignment. And then the next thing that after we fill out some of those is like, what's something that you did share? Like you were excited to share it with someone, you were excited to like build it and create something. So I'll add my own stuff too. I don't want to write on top of anybody. My course was. Yeah, drawings of the human body. And this is something that you just never shared. So I guess with your Python, you never shared any of those with people. That's too bad. Oh. Oh, you made a script? That's awesome. Oh, I mean, if you made a script that your team acted out, it sounds to me like that could be something that you did share, where you're actually sharing it with the with your class. Do you mind if I move that down to something that you did share, or does it feel like too?
Oh, yeah. I guess I was thinking like only within the class and not beyond the class.
Yeah, so I guess for me, I'm thinking like, even if you share it within the class, that process of like communicating and getting people to understand what you were thinking about, even that is like a learning process, part of the learning process.
Yeah, you could move it. It's
Yeah,
like a
all right.
compare, contrast.
Yeah. Because like for me, a lot of things that I never ever shared would be like, I don't know how many exams I've taken at this point, and I've never shown anyone an exam that I took. Yeah, and the drawings of the human body, that would be so cool, because it would be great if you had like a portfolio, like a website full of human body and bones and muscles. Oh, and the lab assignments, nice. Yeah, and so many homeworks, right? All right, so now let's take a look. So we already have one example of like creating a short script and then a team acts it out. What would be some other things that you were excited or you were happy to share with other people? Like you took the assignment and yeah, either brought it home. And the simplest examples could be like you put it on the fridge, like you were just excited about it. Or more involved examples might be like if you made a video and you shared it on YouTube, or you built a project that's now part of your like engineering portfolio. Oh, wow, COVID detection. That's really cool. And you shared some tutorials on quantum computing. The macaroni art. Preschool and kindergarten, they're so my oldest son is now in first grade, and my younger son is in preschool now and doing preschool again next year. The lessons there are so underrated. Like right now they were learning about like being okay with your feelings. And so like that's such a great lesson that I would love to relearn as an adult, and sharing and all these kind of things.
Learning emotional intelligence, awareness.
Oh my God, yeah. So important and so underrated. Ooh, a secret dance class. That sounds awesome. Okay, so now the last part of this exercise is, because you shared something, what was something that you learned in that process? Like when you think about like the example. So for me, my example was in my intro to philosophy class, I wrote this essay on free will. And I was so excited about it. Like I loved reading Sartre I was reading Camus in the class. I wanted to talk about like engineering and free will and whether or not like both can exist if you have this kind of stuff. I was so excited about it. And the professor was like, he was excited about it because I was excited. And then I turned it into like some kind of writing, like a magazine kind of competition. And I won, I think, $20 or something because this was accepted. So the thing that I learned from that was, I mean, I learned a lot about existentialism because I did a lot of research trying to talk about the project, but that was part of the course. Like that's what I was supposed to learn. But I also learned like how to communicate my excitement, how to take my ideas, kind of organize them from just sort of a rambling bar conversation on free will to an actual like paper that is broadly readable. So I'll add some of my stuff. Yeah, and incorporating feedback, that's like such a great skill to have that you don't really get that from an exam. I guess this is one of the main points that I wanted to kind of bring up with this exercise. When you get an exam, and there's some studies that have shown this, if you have an exam and then the professor kind of writes down, or I write down, like I mark off and say, these are all the things that you did wrong on this exercise or this problem. The only thing that our brain sees is that the grade, the number, whether it was like an 85 out of 100 or a 95 out of 100. And immediately our brains are defensive and think they ignore all of the feedback that we just got from that exam. So there's no like future learning from just getting a mark, getting one grade. So incorporating feedback, it's so hard to do that in a classroom environment unless there's some way that you're actually going to share this, whether it's with other people, with other students in the class, with something. And KiCad, all the keyboard shortcuts. Yeah, all those kind of skills. There's no room in the classroom for it, but really good skills. And the script and drama class. Yeah, it has to, the script, you can have this idea for kind of the perfect script, but you do have to work with who you're working with. Like you can't write for Hugh Grant and then go cast Jim Carrey and expect the same script to work in the same way.
You tell the actor, I'm trying to expand your roles. I'm not trying to typecast you.
Yeah. I mean, and you can expand, but at the same time, like if they have input of like, no, that's not the way I do things, you got to roll with it. Like,
yeah, with the class, we did a range of like super improvised, like you just start from nowhere and you yes and people, and then we tried something more scripted, and then we try to do something in the middle.
Oh man, yeah. See, that's awesome. Thank you for sharing. Oh, and one thing, I didn't mention this at the beginning, but at any point you can stop me and ask even questions like, is this relevant anymore? Or like, how is this connected to NumPy? But so one of the things that I'm trying to do to answer my own question of like, how is this connected, is that when I was using tools that were all like textbook based and exams, there was a closedness to the material, which created a closed-mindedness about the product that students were creating. It's a lot of work to go through and like write programs for classes, like writing PID tuners for a systems project, using Python to do all of your dynamic systems work, like all of that. It's a lot of work, and you should be able to reuse that. But if you're kind of embedding students in this closed source system where nothing is supposed to be shared, it's all kind of, there's this like myth that plagiarism can't exist and you learn, but it's like, but plagiarism, like active plagiarism where you're copying and pasting and claiming that work to get credit for it, that's wrong. But copying and pasting and revising and adding your own intellectual property to that, that's just life. That's the way you're supposed to work. So I try, whenever I'm building any kind of open educational resource, openness is the biggest part, because I want the students to be embedded in this open system where they know that the things that they're building can be shared, even if they don't plan on sharing it. That I want them to have these like this NumPy work that they can bring and immediately use it in their next job or show it as a engineering portfolio. And then the side benefit to that is that when you're sharing something, you're learning. That's the biggest part of learning that is a lot of times kind of skipped over, where we kind of say, okay, you learned it, you demonstrated, let's move on to the next step. But if you're not sharing it, like if you're not excited about sharing it, or even if you're not forced to share it, then you miss out on a lot of learning opportunity there. So NumPy provides a lot of that opportunity in learning. Thank you for sharing those exercise work. So this goes into kind of my, the learner's journey, I call it, because I kind of taking John Dewey's philosophy of education and then the Joseph Campbell's hero's journey like cycle, and kind of smushing those two together. That I like to identify like who's in the class and what knowledge they already have, and then introduce like, hey, we have this new thing, like identifying the previous knowledge. For me, with engineers and NumPy, a lot of times that would be saying like, all right, you already know how to use Excel. Let's see if we can use NumPy to make it a little easier to read and maybe more reproducible. And then an added benefit is that now it's also open source. Then do problems either together or kind of like give them some work where they're working towards a solution. And then some kind of project where they're building something on their own. Then once they've built that project and kind of finished that work, that they've achieved some goal, like they've demonstrated that they can use this new model, then sharing that work. So a lot of times they're sharing it with each other or they're submitting it through GitHub, but submitting that project and communicating it, that's what's really leading to those like new knowledge and new skills. So this is all like a framework that I use as I'm kind of building and using NumPy in my classes. Let's take a look at an actual example. I like examples. So let's open in a new tab. This is my Computational Mechanics open educational resource. I build all of these with a Jupyter book, which is also a really awesome tool, but this is a NumPy talk. But I would highly encourage Jupyter Book and Jupyter Hub if you're looking for anything to share, like the work that you have. So I'll take a look at this like first module. I split this resource into 5 modules that we work through throughout the semester. So first is just like a general, how do you work with Python using print statements and using what variables there are. I talk about some good coding habits and file naming, and just some like general, like here's an intro to Python, and then like how to use NumPy. Like you can use multi-dimensional, you can access and slice arrays. So here, let's go into like working with Python, because that's where we get into some NumPy work. And yeah, this is kind of like good versus bad programming work of naming your function code is not very helpful, but if you name it factorial function and give it an actual docstring, that's a much better way of using like creating a function, even though on paper, like whenever you look at the result, it is the same result in both cases. So after going through kind of these reading materials and coming down to like playing with NumPy arrays, then the students, this is where they're introduced to like that new model. And then I give them some problems to work on. So here in part 1, create like finding volume of a box and comparing some strings. And part 2, like actually using NumPy to create like a multiplication table. Like, oh, NP not defined. I should define it in the and then creating like a linear interpolation. So all these are like little problems where we're all trying to work together to solve these problems. And again, the answers that they come up with this is all work that can be reused because it's all open. And then finally, for the project, now we're introducing like this numerical integration scheme. So using NumPy to approximate this. And here it's a kind of a macabre application, but looking at the temperature change of a corpse over time to try to figure out what was the time of death here. And the reason I'm bringing up this one is because I have an active class right now, so I can head over to the repository. Oh, let's open that up. And in here, I have this active discussion board where we're talking about, like right now we're looking at homework 4, kind of coming up to the end of this summer session. But we can talk about all these projects, and I'm not the only one submitting the answer. Like the students are all working on this and they're sharing each other's answers. Yeah, we've got 3 pages of discussion of things going on. And then if you look at the code itself, oh yeah, over here. I have them, just have to get this. I want to look, there we go, view existing forks. Everyone who takes this class has a fork of this course, like all these course materials. Some of them keep their work up to date. Like I give them a little tutorial about like how to keep your work up to date on your fork. Some of them go through that because they like learning a little bit more. Others just kind of do the work and submit it however they need to. Am I still connected? Yeah, we're good. Some of them just do that, but now I have 154 like different forks of this material, and it's all open work. They can reuse this however they want, which is very different. It's a very different model from like a textbook, where even though you're giving that textbook to a student, it immediately loses value and it can never be changed. The only people that can make change are the publishers. here it's a collaborative effort where we're building this textbook together. Students are posting issues on the GitHub repository, and we can continually improve or change these resources. So this is education is a social process. It's growth. It's education, at least to me and to John Dewey. It's just recognizing like how you're growing and how you're changing. So it's not preparing you for life. It is your life. Like you are learning like as you're going through life. So trying to separate and say like, okay, here's your textbook and this is your closed source. Like there's no reason to learn, no reason to recreate this. It's very synthetic when really we should be talking to each other, collaborating, kind of incorporating these new knowledge and skills into our previous knowledge set. What questions are there so far? I love talking about like philosophy in general, sort of journeys and stuff like that. So I did get a little sidetracked from NumPy in engineering.
Is this the Q&A section?
It's not the Q&A section, but I want to pause before I just keep like bombarding you with more, more stuff.
Oh yeah, you didn't you didn't sidetrack. It was actually very interesting to get these insights. And like the whole time you've been presenting, I was wondering how positive my previous learning experience could have been if I was under a different model of teaching. I think that we are oftentimes isolated into individual multiple clusters, and I think we lose a lot when we're submitted to learning in that manner.
Yeah, and that's absolutely right. Like the old school way of teaching is sort of like there's someone giving you information, and then as much as possible you like separate everyone. So like exam structures, there's such a high stress environment, and I mean it's been demonstrated over and over that the feedback you get from an exam is not giving you any new knowledge. So it's all this extra stress for very little learning payoff. It's purely like a faux quantitative, like it's trying to be quantitative, but it's trying to quantify a very qualitative idea of like how much did this person learn. Yeah, thank you for sharing. I agree. And that's how I had learned engineering. So I'm trying to break the cycle, use open resources, build an open classroom. And it is a very different way of approaching this kind of work. So I use NumPy in every class that I teach. So we were just looking at that computational mechanics page. I also built these labs. Myself and another professor, we totally redid all of our intro to sensors and data. This is like a mechanical engineering lab 1. Like the first thing that we do is showing students the student t-test. So it's a statistics idea of using how well do you know the mean to try to decide like are two different things actually different. And in this case, I call it like the marble madness design problem, where you're given 3 different bins of marbles, and then now you use NumPy to figure out, is there a difference between A and B or A and C? And you know A is like a good set of marbles, so you want to figure out if B or C are the bad set. And then the other thing, so these are bigger classes, like applied dynamics, computational mechanics are kind of 70-ish students. These lab classes are usually around 200 students. But then I also use NumPy in smaller, even just independent study kind of projects. So what we did, this was 2 years ago now, based on how much activity we've had recently. But the goal was create a NumPy tutorial based on something from class. And so over the course of a semester, so 15 weeks, myself and 3 students, we were working on these different notebooks and Daniel actually submitted this one to the NumPy tutorials website. Sorry, yeah, the website. So we have a GitHub portfolio full of NumPy tutorials, and this was his like engineering application of solving equilibrium using Newton's second law for like some of the forces and some of the moments on. Let's come down here. I want to bring it down to his. Yeah, so he had like this column with a cord trying to keep it upright and solving for what are all the reaction forces in these things. So a very standard kind of mechanical engineering problem, and a very cool application of NumPy of using like vectors and arrays to actually create this Newton's second law application. So some of the benefits that I've been talking about, and we don't have much time left, so I won't get into, I was going to make you do an example to show you how cool it is, but we'll skip that and just do questions. So some of the benefits is that the students are leaving with actual open projects. They're building portfolios, reusing resources, and ideally they're redistributing. But at a base level, they're sharing at least with each other. But because it's completely open, they can share with anyone they want. It's not limited to the classroom. And it's not tied to restrictive licenses or ecosystems. So they're not stuck in Visual Basics because they had done like a project in Visual Basic and now they have to use that for the rest of their life. I mean, NumPy is a great open and friendly software, like set of software and tools. Some of the benefits of the experience is that all this homework and all these projects are built to share. So you share them with the class, you share them with a broader audience, and we're improving these resources together. So it's not a static textbook that can never be changed. This is something that can develop, that can have positive changes even within a semester with the students. And this is generating a ton of other transferable skills, kind of like we were showing with our shared projects from classes. In this case, they're getting some online community engagement. We're using discussions on GitHub. In the past, we've used other discussion forums, but the GitHub discussions have been really great, especially since they added equation editors. You can use LaTeX equations. I've been begging for that for like 4 years now, and it's finally in the GitHub Markdown. Programming skills and scripting. And some of these classes are not programming classes, but because the tools are there that they can reuse for other courses, they end up reusing them in all sorts of courses. They're getting collaborative teamwork, technical writing and communication, because as you're trying to share something with someone else, you have to communicate that. You can't just have an unreadable script that does something every time you run it from the command line. And the biggest benefit of NumPy, it's just fun. It's just so much fun to use. It makes engineering like cool. And at least for me, I like this kind of programming kind of work. But the students, there's also a lot of students that feel the same way, that they feel like they're more engaged and it's just more fun to use Python and NumPy and the whole SciPy ecosystem.